Okay, so you see the fun description, and then you have to give me the actual boring description of the factors. But hopefully, with this activity, this boring description will also stick to your mind. Okay, so BFFS, according to me, best friends forever. FM is female and male. FA is free access. FSC is free lunch for children, and TRD means tension reduces dopamine. Okay, so what is the actual description of each of these words? Okay, and I'm hoping it will not work the other way around, that you forget the actual description and in the exam you write, you know, the one. Okay, so you guys remember. Okay, TRD is total ramp density, absolutely true. Base free flow speed, BFFS, yes. Right again, Haya, Haneen, both are correct. Okay, so the first one is done, the last one is done. In the middle, we have three more. Okay, FM, FA, and FLC. What do we mean by that? Obviously, in each one of them, F means a factor. You have to think about what MA and LC means. And this is exercise is just to refresh your mind. So if you look at the slides or notes, I don't mind. Okay, I just need you to know what these terms mean. Lateral clearance, yeah, FLC. I think you mean lateral clearance with FLC. That's correct. Factor for lateral clearance. Yes, there are no free lunches in this world. So Ranim is correct. Mariam is also correct. Factor for access points. Okay, access point or access point density. FM is not factor for maneuver. No. What is FM? Anyone else? Yes, thank you, San. I know that. I have a very large collection of these fun descriptions, but I will not give all of you to you. You must devise your own. Okay, FM. It's not factor for maneuver. Then what is it? Factor for what? Median type. Yes, Mariam. Good. Thank you. So BFFS, base free flow speed, which can be your best friend forever. Factor for median type. FM is factor for median type. Okay, and it doesn't have male or female. FA is factor for access point density. Okay, and yes, on highways access is free normally. And FLC, free lunch for children. There are no free lunches, so this is for lateral clearance. TRD, tension reduces dopamine. It does. Okay, it does reduce dopamine tension. Okay, so don't take tension. Just count the number of ramps. Okay, total ramp density. That's it. Okay. So moving on to the topic itself. These factors, I can move on to the calculation of free flow speed. Okay, so we start with an example which has data for freeway as well as the multi-lane highway. Number of lanes, lane width, lateral clearance on the right hand side is given for both of them. And then the other data is on need basis. So for freeways, freeways always have a median. So you don't need to specify what type of alignment is it. But for multi-lane highways, you need to specify because multi-lane highways can be divided or undivided. Okay, but this one is undivided. A base free flow speed is only required for the calculation of multi-lane highway free flow speed. So that is given. Ramps per mile are only collected for freeways, so they are not there for multi highways. Access point density is not required for freeways, it's only required for multi highways, so we have it here. Okay, so I start with the calculation of freeways. And the calculation of freeways, you need basically three things. All of them are mentioned here. The lane width, the letter clearance, and the ramps per mile. Okay, the equation is okay, the equation for freeways is this one. Keep in mind 3.22 is multiplied by TRD and 0.84 is the power of TRD. Okay, so I need three factors here. FLW, which is a factor for lane width, as you said. So for factor of lane width, I have a table here. Okay, lane width for freeways was given as 12 feet. Okay, so for 12 feet, the factor is 0. This factor is 0. Then I need factor for letter clearance. Letter clearance depends upon number of lanes and the right side letter clearance for freeways. So I had a 6-lane freeway. If you go back to the question, it has 6 lanes. So 6 lane meaning 3 lanes in each direction. Okay, and right side letter clearance was given as 4 feet. So 4 feet from here, 3 lanes in one direction. The factor is 0.8. TRD is given as 4 ramps per mile. No table for that. The value is directly given in the question. So give me the value for FFS for this freeway. $64.3. Okay, fine. This is good. Okay, now I can do the same thing for multi-lane highways as well. Multi-lane highway, the equation is this. Equation is simpler, but it has more factors. Okay, BFFS for multi-lane highway given as 65 miles per hour in the question. Okay. Lane width is given as 11 feet for the multi-lane highway. So if I go back to the table, lane width for 11 feet, the factor is 1.9. Okay, the next factor is for letter clearance. Now for letter clearance, I need total letter clearance of the multi-lane highway, including right plus left hand side both. Okay, now if I go to the question, you will see that the letter clearance on the right hand side is given, which is 2 feet. Letter clearance on the left hand side is not given, but I need total. Instead, they have told me that it's an undivided multi-lane highway. Now regarding this point, I mentioned it on Thursday as well, that when you have an undivided multi-lane highway, the actual letter clearance on the left hand side is 0. There's no clearance on the left hand side. But since I already have a factor for undivided highway, I will keep the letter clearance on the left hand side as 6 feet, which is a standard value. Okay, because if you take it 0, then you are you will do the adjustment for 0 feet lateral clearance, and then you will do again adjustment for undivided highway. So that will be 2 adjustments for the same reason. We don't want to do that, so we'll just keep the lateral clearance on the left hand side as per standard, which is 6 feet, and you will add it with the lateral clearance on the right hand side, so it's 2 feet. So 6 plus 2. Okay, and then you will use the adjustment factor for the undivided highway. So the issue of undivided highway was only considered in one of the factors, which is the median type, and the other one it was not considered. Okay, so let me write it here as well so that you guys don't forget. So total lateral clearance is 2, which is for the right hand side, plus 6, which is because of the undivided highway. If it wasn't undivided, then they should have given us the lateral clearance on the left hand side as well, and then I would have added that value directly. Okay, so this is 8 feet. So the factor for lateral clearance, it's a 4-lane multi-lane highway, and the total lateral clearance is 8. So the factor is 0.9. Okay, then I need the factor for access point density. We have 20 access points per mile. For 20 access points per mile, factor is 5. Okay. Now in this table, interpolation is allowed. So instead of 20, if I gave you, let's say, 23, then you can interpolate between 20 and 30. Okay. So in this table, interpolation is allowed. But for the time being, we have exact value 20. Factor is 5. So 5. Median type, median undivided. Okay, so for undivided highway, the factor is 1.6. Okay, how much is the free flow speed here? So you just take 65 and just subtract all the factors. That's it. $55.6. Okay, thank you. Okay, so whenever you are doing any analysis related to multi-lane highways and freeways, and that involves level of service or capacity, then the first thing you need to do is find out free flow speed. Okay, and I will repeat myself again because it's very important that free flow speed can be found in 2 ways. One is using those equations like we did. The other one is what we have already done in the second submission of the term project, which is to go on the highway in free flow conditions and observe the speed and find out the mean of the spot speed, like you have done or like I have asked you to do. So that is another way of finding out the free flow speed. After finding out the free flow speed, then you can perform 3 types of analysis. Okay, and in all 3 types of analysis, level of service is the important part. Okay, so we can perform operational analysis, service volume and service flow rate analysis, and design analysis. So we'll discuss each one of them and their equations, and inshallah tomorrow we will look at some examples as well. The first one is operational analysis. Operational analysis means that you have an existing highway and you are trying to find out its level of service under prevailing conditions. The highway is already there, it's existing, it's operating, and you want to find out what is the level of service under the given conditions of the highway. That is operational analysis. For that, the main equation, we need 2 main things. First is already calculated free flow speed. The second one which we need is flow rate, VP or flow rate. So VP is calculated as the volume, okay, the actual volume on the highway, and usually it will be the volume of the peak hour, right? Volume of the peak hour in vehicles per hour, then divide by 3 factors: peak hour factor, PHF, capital N, number of lanes, okay, and FHV, factor for heavy vehicles, okay. So PHF, peak hour factor, and number of lanes, FHV, factor for heavy vehicles. After dividing by that, you will get VP, which is in passenger cars per hour per lane, okay. And we have already seen VP in the speed flow diagram as well. So after calculating VP, then you can move on to the calculation or the determination of the level of service. Another type of analysis is service flow rate and service volume analysis. Service flow rate means the maximum flow rate you can have under a specific level of service. Okay, so you can see in the service flow rate equation, I'm using a subscript I. So I is basically the subscript assigned to the required or the targeted level of service. What level of service you require at the highway, what level of service you are targeting at the highway, that will be replaced with I. Okay, so I can be A, B, C, D, E. Okay, so you want to calculate under the prevailing conditions of the highway what maximum service flow rate I can have, or what service flow rate I can have to maintain level of service I. Okay, in service flow rate or service volume analysis, our aim is to find out the service flow rate that can, or the maximum value of the service flow rate under the prevailing conditions that can still maintain my required or target level of service. Okay, let me say it again. In service flow rate analysis, you are trying to find out the maximum value of the service flow rate under the prevailing conditions which can maintain the required or the target level of service I. So in this equation, you can see I need three things. N, like I've already mentioned, number of lanes. FHV, factor for heavy vehicle adjustment. MSF stands for maximum service flow rate. Maximum service flow rate. Now, what is the difference between SF and MSF? SF is service flow rate under prevailing conditions. MSF is maximum service flow rate, which can be only in ideal conditions. Okay, so MSF is maximum service flow rate for level of service I under ideal conditions. We call them the base conditions as well. So base conditions, ideal conditions mean the same thing. So the difference between SF and MSF is the conditions. SF is calculated or is being calculated under prevailing conditions, and MSF is a value which is under ideal or base conditions. Okay. Then once you have calculated service flow rate for level of service I, you can convert it to service volume as well for the same level of service by multiplying with the factor peak hour factor. Okay, by multiplying with the peak hour factor. So service flow rate can be converted to service volume, and again for the same level of service. Now so who can tell me the difference between SF and SV, or just simply flow rate and volume? Who can tell me the difference between flow rate and volume? We have discussed in multiple chapters and multiple topics the difference between flow rate and volume. Tell me. What is the difference between volume and flow rate? Volume counts for 1 hour at least. Okay. A small correction. 1 hour at least. It can be more than 1 hour as well. Flow X, for example, number of vehicles in 15 minutes. This is, if you multiply by 4, it becomes flow rate higher. When you multiply by 4, it becomes flow rate. When you don't multiply by 4, it is only flow. Okay. Counts for less than hour, converted to hourly. Yes, this is what I'm saying, Hashim. Yes, so Hashim and Haya both are correct, but with a small clarification. Okay, volume can be at least for 1 hour, can be more than 1 hour as well, and flow is only 15 minutes. When you multiply by 4, it becomes flow rate. So you are converting it to hourly. That is fine. Good. Thank you. Moving on, the third type of analysis is design analysis. In design analysis, we are trying to design the highway. So we have a future condition, and we want the design of the highway for future. Now the parameter of design which is directly linked with level of service is number of lanes. So you can see the equation here for number of lanes, N, capital N. And I again refers to the level of service which you are targeting in the future peak hour. Okay. But there are many other things which affect level of service, or level of service can affect them. For example, in the free flow speed equations, we have seen many factors, right? Median type, letter clearance, lane width. So all these factors are also indirectly affecting the design. Okay, or the level of service can also indirectly affect lane width, median type, TRD. Okay, and even in this equation, it is affecting factor for heavy vehicle, peak hour factor. Okay, DDHV. Okay, so these are, but one thing which we directly link with level of service is number of lanes. Okay, all the other factors have some indirect link. Okay, so when you change the design, you can see the effect of other factors as well on the level of service for future design. You can do that. Okay, but for the sake of our convenience, we have a direct link with the number of lanes. So that the factor which is directly calculated using level of service is number of lanes. Okay, so as I said, design analysis, we are trying to find out how many lanes should I provide for the future prevailing conditions to maintain level of service I. Okay, how many lanes should I provide for the future prevailing conditions on the highway to maintain level of service I? So in future I want to maintain level of service B. How many lanes should I give to have level of service B in the peak hour on the highway in future? Okay, so that is the analysis. DDHV stands for directional design hourly volume. Okay, the future peak hour volume, peak hour factor, MSF, FHV, I already discussed them. Peak hour factor, MSF, maximum service flow rate, again for level of service I under ideal conditions, and FHV is the heavy vehicle adjustment factor. Okay, now you have seen in the equation which I have showed you for all three types of analysis, operation, design, and service flow rate, you have seen one factor was common, that was FHV. There are other common factors as well, but we have already discussed them. Okay, I showed you peak hour factor. We've done the calculation for peak hour factor. We have done the calculation for DDHV. Okay, but factor for heavy vehicle adjustment we have not covered before. So let us talk about this factor for the remaining part of the lecture today. Okay, first of all, this factor converts the combined volume, traffic volume, into its equivalent passenger car volume. FHV is used to convert combined traffic volume into its equivalent passenger car volume. Combined meaning what? Combined includes passenger cars plus heavy vehicles. Okay, combined includes passenger cars plus heavy vehicles as it is. So number of vehicles. Okay, you just add them together. But in FHV, after using FHV, that combined volume converts into its equivalent passenger car volume. Okay, let us see how. So FHV is calculated using this equation. Before using the equation, first of all, you must understand how the highway capacity manual defines heavy vehicles. According to highway capacity manual, heavy vehicles are defined as those vehicles which have more than 4 tires touching the pavement, which have more than 4 tires carrying the vehicle itself. Okay, now everybody, all of us has a spare tire in our car, right? So that spare tire doesn't make our car as heavy vehicle because that spare tire is not operating, is not touching the pavement, it's in the back of the car, back of the car. Okay, it's in the bonnet or dicky, whatever you call it. Okay, so any vehicle which has more than 4 tires touching the pavement, carrying the vehicle, is a heavy vehicle. Okay, so if you can find some way to put a 5th tire in your car and which is touching the pavement, your car will become heavy vehicle as per highway capacity manual. I'm not saying that. Okay, then highway capacity manual defines or classifies the heavy vehicles into 2 further categories, SUTs and TTs. SUT stands for single unit truck. Okay, so SUC stands for single unit truck, and TT stands for trailer truck. SUT, single unit truck, TT, trailer truck. Single unit truck is usually smaller, okay, and it has only one compartment behind it in the rear, okay, only one loading unit behind it. Trailer trucks are usually longer and heavier, and sometimes they carry multiple units, multiple containers or something, okay. So single unit trucks are smaller of the heavy vehicles, and trailer trucks are bigger. And then if you go back to the equation which you see on the right hand side of the slide, we need two things to calculate FHV. Okay, PHV and EHV. PHV stands for proportion or percentage of heavy vehicles in the traffic stream. Proportion or percentage of heavy vehicles in the traffic stream. So for example, you have 4,000 total number of vehicles on the road. Out of 4,000, 500 are heavy vehicles. So PHV will be 500 upon 4,000. 500 number of heavy vehicles divided by total. That will be PHV. And then we need another factor which is EHV. EHV means passenger car equivalent for heavy vehicles. Passenger car equivalent for heavy vehicles. Okay, so this is the equivalency factor to convert one heavy vehicle into its number of passenger cars. Factor to convert one heavy vehicle into equivalent number of passenger cars. Okay, so if the factor is, for example, 2, so that means one heavy vehicle equals to 2 passenger cars. Okay, so obviously passenger cars take up more space on the road. They are slower. So if you say factor is 2, that means the effect which one heavy vehicle has on traffic is equal to 2 passenger cars. Okay, so EHV is the effect of one heavy vehicle compared to a passenger car. Okay. And this effect, this value of EHV mainly depends upon the terrain or the topography of the highway. Terrain or topography of the highway. Now for the calculation of EHV, not the calculation, sorry, don't get scared. I mean for finding out the value of EHV. So there's no calculation for EHV. You just find out the value from some tables. For finding out the value of EHV, we need to classify, or we need to find out what type of terrain conditions we have. So according to Highway Capacity Manual, for getting the value of EHV, there are two main classes of terrain. There are two main types of terrain. One is known as general terrain, and the other one is known as single extended gradient terrain or extended gradient terrain. Okay, general terrain or extended gradient terrain. Okay. Now, how do I know which type of terrain I have? For extended gradient terrain, there are 2 points. If you fulfill any of these 2 points, you have extended gradient terrain. What are these 2 points? The first point is that your gradient is less than 3%, but it is extended to more than 0.5 miles. The gradient is less than 3%, and it is extended to more than 0.5 miles. This condition fulfills extended gradient condition, extended terrain condition, extended gradient terrain condition. Okay. Second point is the gradient is more than 3%, but it extends to more than 0.25 miles. Then again, it fulfills extended gradient terrain condition. Okay. So for extended gradient condition, there are 2 points. If you fulfill any of them, you have extended gradient terrain. The first one is the gradient less than 3% extended to more than 0.5 miles. The second point is the gradient more than 3% extended to more than 0.25 miles. Okay. Now let's say you don't fulfill any of these conditions, then you have general terrain. Okay. Whenever both these points are not fulfilled, then you have general terrain. Okay. And again, general terrain can be further subclassified into 2 types: level and rolling. Level and rolling. Level means the gradient is even less than 2%. Level means the gradient is less than 2% and it is not causing a significant change in the speed of heavy vehicles. That is level terrain. Rolling terrain is the gradient is close to 2%, maybe slightly higher than 2%, but it is causing or the general design of the road is causing the heavy vehicles to reduce their speed significantly. Okay, so on rolling terrain, you have significant reduction in the speed of the heavy vehicles. And rolling and level both are types of general terrain. Okay, so first of all, you will check whether I have general terrain or extended gradient. If you have general terrain, then you will see whether you have level or rolling. Okay, in some cases, the rolling terrain may cause the vehicles to slow down up to a crawl speed. Okay, so crawling speed is that irritating condition of the driver of the heavy vehicle where a pedestrian is passing by him and he's waving at him. See, I'm going faster. Okay, so crawling speed is when the vehicle is moving, okay, but it's very, very slow, maybe like around 10 miles per hour or something. Okay, and that is because of the terrain, not because the traffic jam or something else. Because of the terrain, the heavy vehicles has become so slow that it is a pedestrian can even pass it without any problem. Okay, so the word crawl comes from the crawling of the babies, right? When the babies start to move themselves, they crawl on hands and knees, right? So that is crawling. That is crawling. Okay, and obviously at that time they are very slow, and thankfully to the parents. Okay, otherwise they will go anywhere. Okay, so for level and rolling terrain, we have a single table which you can see at the bottom. For rolling terrain, EHV is 2. For level terrain, EHV is 2. For rolling terrain, the EHV is 3. Okay. Now, if you have extended grade condition, then we have 3 basically choices for taking the value. The first one is take it from this table. This table is used if you have a default or normal mix of TTs and SUTs, trailer trucks and single unit trucks in the heavy vehicles. What is the normal mix or what is the default mix of TTs and SUTs? 70% SUTs, 30% TTs. This is called as a normal or default mix. 70% are single unit trucks or smaller trucks and 30% are trailer trucks or bigger trucks among the heavy vehicles. That is normal or standard or default mix. Okay, then in that case, take the value of EHV from this table, provided that you are in extended grade condition. Okay, so what do I need to use this table? I need the value of the gradient, I need the length of the gradient, and I need to know the percentage of heavy vehicles. Combined percentage of heavy vehicles. Combined, okay, TTs plus SUTs, what is the combined percentage then? Okay, and again, if you do not have the exact value, you can interpolate. So instead of 15%, you have 16%. You can interpolate between these numbers, no problem. And if you don't have the exact length, which is shown here, again, you can interpolate. So within the table, interpolation is allowed, applicable. But for example, the mix which you have is not exactly normal. Not exactly normal, but close to normal. Even then, the use of this table is allowed. Okay, so the mix can be approximate. Okay, so instead of 30-70, you have maybe 35-65. Still, you can use this table, no problem. Okay, so the mix, the percentage of the mix can be taken as approximate, no problem. Okay, so this is the previous one was for standard or default mix. This table is when you have heavy mix or equal mix. Heavy mix means what? 30% SUT and 70% TT. So this is the inverse of normal mix, right? The heavy mix is the inverse of normal mix. Normal was 30% TTs, 70% SUTs. Heavy is 70% TTs and 30% SUTs. Then you will take the value from these 4 columns, and then you can have equal mix as well. 50% SUTs, 50% TTs, and you will take the value from these 4 columns. Again, interpolation is allowed, and all the values are the same, like the values required are the same. The value of the gradient, the length of the gradient, and the percentage of total heavy vehicles, total number of heavy vehicles. Okay, and again, interpolation is allowed, and then you have to decide what approximately represents your mix. Okay, do you have approximately equal mix? Like I said, okay, you may not have exactly the same percentages for which the table is. But if you are close to this, fine. Okay. But this table and the previous one is only used for extended grade condition. Extended grade condition. Okay, let us do an example of how FHV can convert vehicles to passenger cars. How FHV can convert the combined volume into equivalent passenger car volume, and it can be done in two ways. There are two ways to do it. I'll show you inshallah both. Okay, the first way in which we can do it. First of all, let us read the question. Freeway operating in general terrain, rolling terrain. Okay, so it's not extending gradient to level, it is rolling terrain. Traffic composition is 12% trucks, 3% RVs. RV stands for recreational vehicles. Okay, now I may have explained the term earlier. I'll not go into the explanation again because it doesn't matter to us for the purpose of EHV or FHV. Okay, RVs are also part of the heavy vehicles group. So whatever the number of RVs is, you will just add it with the percentage of trucks, and that's it. Okay, so you don't have to get confused or worried about what should I do with RVs. RVs are also type of heavy vehicles, so their percentage will be added to the percentage of trucks, and you will get the combined percentage of heavy vehicles. That's it. The observed peak hour volume is 3200 vehicles per hour. So this 3200 includes 12% trucks and 3% RVs. Okay, and the remaining are passenger cars. What is the equivalent volume in passenger cars per hour? Okay, so to do it, like I said, you can do it in two ways. The first of the thing we can do is use FHV. Okay, so the equation of FHV is this. Let me write down the values. So 1/1 plus PHV. PHV is percentage of heavy vehicles. I have 12% trucks, 3% RVs. Total is 15%. Total percentage is 15%. So 0.15. Now this is one mistake which some of you made in the exam. This one, the last one, that you were putting the percentage as it is. Percentage in the denominator cannot be put as a percentage itself. You have to divide by 100 and put it as fraction. Okay, so 15% will become 0.15. Okay, then I need EHV. EHV for rolling terrain. Okay, so for rolling terrain, EHV is 3. Okay, so 3 minus 1. Minus 1 is from the equation. Give me the value of FHV, factor for heavy vehicle. One 769. Okay. Now you want to calculate equivalent passenger car volume. It will be volume in vehicles per hour divided by FHV. So this is one way of converting the volume from vehicles per hour to passenger cars per hour divided by FHV. So how much is this? $4162. Okay. Now this 4162 is now passenger cars per hour. Okay. It has converted to passenger cars per hour. The actual volume is 3200 vehicles per hour. It has been converted to 4162 passenger cars per hour. This is one way of doing it. Another way of doing it is by using the EHV directly. You can use the EHV directly. Okay. And how to use it? We will multiply it with the number of heavy vehicles we have in the mix. Okay. So number of heavy vehicles, or let's say the volume of heavy vehicles, is 3200 into 0.15, right? 15% are heavy vehicles, right? So how much is it? Out of 3,200, what is the volume for heavy vehicles? 480. Okay, so if you subtract this 480 from 3,200, the remaining are passenger cars, right? The remaining are not heavy vehicles. That means they are passenger cars. So what is the volume of passenger cars we have? 3,200 minus 480. How much we have? 2720. Okay, now to convert these heavy vehicles into passenger cars, I will multiply with the equivalency factor. Okay, so VHV converted to passenger car, so I will call it VHVP. Okay, it's not in the book, I'm just innovating the term. Okay, so this is heavy vehicle volume converted to passenger car. So it will be 480 multiplied by the equivalency factor 3 EHV. I'll directly multiply by 3. How much do we get? EHV for rolling terrain again, because terrain is the same. Okay, now if you want VP, now just add the passenger cars you actually have, which is 2720, plus the equivalent volume of heavy vehicles, which is 1440. How much would you get? 4160. Again, this is passenger cars per hour now. Okay, and you can see it is very close to the value I calculated using FHV. Very close. Okay, obviously there can be some approximation. Don't worry about it. Okay, if you are getting 1 or 2 numbers plus or minus, don't worry about it. We are rich people. We can afford 1 or 2 cars more or less, no problem. Okay, but both methods are correct. They will approximately give you the same answer. In the first method, you divided the volume with FHV. In the second method, you have multiplied the number of heavy vehicles with the equivalency factor and added with the passenger cars you already have in the traffic. Okay, so is it clear? Do you have any questions? So there's still a small part left regarding the calculation of heavy vehicle factors. Okay, and we'll do it tomorrow, inshallah, and we'll continue to the rest of the calculation for the analysis as well, the operational analysis and so on. And so today we have basically talked about calculation of free flow speed and heavy vehicle adjustment factor. So do you have any questions, any problems? This is where we stopped in section 1. So today is your lucky day. You have 2 extra minutes. Okay, any questions, queries, problems? Everything is clear? Okay, thank you. You're welcome. See you guys tomorrow, inshallah. Have a nice day. Assalamu alaikum.